A brake is a mechanical device that inhibits motion by absorbing energy from a moving system. It is used for slowing or stopping a moving vehicle, wheel, axle, or to prevent its motion, most often accomplished by means of friction. Background. Most brakes commonly use friction between two surfaces pressed together to convert their kinetic energy of the moving object into heat, though other methods of energy conversion may be employed. For example, regenerative braking converts much of the energy to electrical energy, which may be stored for later use. Other methods convert kinetic energy into potential energy in such stored forms as pressurized air or pressurized oil. Eddy current brakes use magnetic fields to convert kinetic energy into electric current in the brake disc, fin, or rail, which is converted into heat. Still other braking methods even transform kinetic energy into different forms, for example by transferring the energy to a rotating flywheel. Brakes are generally applied to rotating axles or wheels, but may also take other forms such as the surface of a moving fluid. Some vehicles use a combination of braking mechanisms, such as drag racing cars with both wheel brakes under parachute, or airplanes with both wheel brakes and drag flaps raised into the air during landing. Since kinetic energy increases quadratically with velocity, an object moving at 10 meters per second has 100 times as much energy as one of the same mass moving at 1 meter per second, and consequently the theoretical braking distance, when braking at the traction limit, is 100 times as long. In practice, fast vehicles usually have significant air drag, and energy lost to air drag rises quickly with speed. Almost all wheeled vehicles have a brake of some sort. Even baggage carts and shopping carts may have them for use on a moving ram. Most fixed-wing aircraft are fitted with wheel brakes on the undercarriage. Some aircraft also feature air brakes designed to reduce the speed in flight. Notable examples include gliders and some World War II-era aircraft, primarily some fighter aircraft and many dive bombers of the era. These allow the aircraft to maintain a safe speed in a steep descent. The Saab B-17 dive bomber and Vought F-4U Corsair fighter used the deployed undercarriage as an air brake. Friction brakes on automobiles store braking heat in the drum brake. A disc brake while braking then conduct it to the air gradually. When traveling downhill, some vehicles can use their engines to brake. When the brake pedal of a modern vehicle with hydraulic brakes is pushed against the master cylinder, ultimately a piston pushes the brake pad against the brake disc, which slows the wheel down. On the brake drum it is similar, as the cylinder pushes the brake shoes against the drum, which also slows the wheel down. Types brakes may be broadly described as using friction, pumping, or electromagnetics. One brake may use several principles. For example, a pump may pass fluid through an orifice to create friction. Frictional brakes are most common and can be divided broadly into shoe or pad brakes, using an explicit wear surface, and hydrodynamic brakes, such as parachutes, which use friction in a working fluid and are not explicitly wear. Typically the term friction brake is used to mean pad shoe brakes and excludes hydrodynamic brakes, even though hydrodynamic brakes use friction. Friction brakes are often rotating devices with a stationary pad and a rotating wear surface. Common configurations include shoes that contract to rub on the outside of a rotating drum, such as a band brake, a rotating drum with shoes that expand to rub the inside of a drum, commonly called a drum brake. Although other drum configurations are possible, and pads that pinch a rotating disc, commonly called a disc brake. Other brake configurations are used, but less often. For example, PCC trolley brakes include a flat shoe which is clamped to the rail with an electromagnet. The Murphy brake pinches a rotating drum, and the Orsko-Lambert disc brake uses a hollow disc with shoes that sit between the disc surfaces and expand laterally. A drum brake is a vehicle brake in which the friction is caused by a set of brake shoes that press against the inner surface of a rotating drum. The drum is connected to the rotating roadwheel hub. Drum brakes generally can be found on older car and truck models. However, because of the low production cost, drum brake setups are also installed on the rear of some low-cost newer vehicles. Compared to modern disc brakes, drum brakes wear out faster due to the tendency to overheat. The disc brake is a device for slowing or stopping the rotation of a road wheel. A brake disc, usually made of cast iron or ceramic, is connected to the wheel of the axle. To stop the wheel, friction material in the form of brake pads is forced mechanically, hydraulically, pneumatically or electromagnetically against both sides of the disc. Friction causes the disc and attached wheel to slow or stop. Ceramic brakes, also called carbon ceramic, are high-end type of frictional brakes with brake pads and rotors made from porcelain compound blends that feature better stopping capability and greater resistance to overheat. Due to the high production cost, ceramic brakes aren't widely used as factory equipment, and their availability on the automotive aftermarket is low compared to traditional metallic brakes. However, being performance-oriented equipment, ceramic brakes are popular among races. Pumping brakes are often used where a pump is already part of the machinery. For example, an internal combustion piston motor can have the fuel supply stopped, and then internal pumping losses of the engine create some braking. Some engines use a valve override called a jake brake to greatly increase pumping losses. Pumping brakes can dump energy as heat, or can be regenerative brakes that recharge a pressure reservoir called a hydraulic accumulator. Electromagnetic brakes are likewise often used where an electric motor is already part of the machinery. For example, many hybrid gasoline-electric vehicles use the electric motor as a generator to charge electric batteries and also as a regenerative brake. Some diesel-electric railroad locomotives use the electric motors to generate electricity which is then sent to a resistor bank and dumped as heat. Some vehicles, such as some transit buses, do not already have an electric motor but use a secondary retarder brake that is effectively a generator with an internal short circuit. Related types of such a brake are eddy current brakes and electromechanical brakes. Electromagnetic brakes slow an object through electromagnetic induction, which creates resistance in turn either heat or electricity. Friction brakes apply pressure on two separate objects to slow the vehicle in a controlled manner. Characteristics. Brakes are often described according to several characteristics including peak force. The peak force is the maximum decelerating effect that can be obtained. The peak force is often greater than the traction limit of the tires, in which case the brake can cause a wheel skid. Continuous power dissipation. Brakes typically get hot in use, and fail when the temperature gets too high. The greatest amount of power that can be dissipated through the brake without failure is the continuous power dissipation. Continuous power dissipation often depends on e.g., the temperature and speed of ambient cooling air. Fade. As a brake heats, it may become less effective, called brake fade. Some designs are inherently prone to fade, while other designs are relatively immune. Further, use considerations, such as cooling, often have a big effect on fade. Smoothness. A brake that is grabby, pulses, has chatter, or otherwise exerts varying brake force may lead to skids. For example, railroad wheels have little traction, and friction brakes without an anti-skid mechanism often lead to skids, which increases maintenance costs and leads to a thump-thump feeling for riders inside. Power brakes are often described as powerful when a small human application force leads to a braking force that is higher than typical for other brakes in the same class. This notion of powerful does not relate to continuous power dissipation, and may be confusing in that a brake may be powerful and brake strongly with a gentle brake application, yet have lower peak force than a less powerful brake. Pedal feel. Brake pedal feel encompasses subjective perception of brake power output as a function of pedal travel. Pedal travel is influenced by the fluid displacement of the brake and other factors. Drag. Brakes have varied amount of drag in the off-brake condition depending on design of the system to accommodate total system compliance and deformation that exists under braking, with ability to retract friction material from the rubbing surface in the off-brake condition. Durability. Friction brakes have wear surfaces that must be renewed periodically. Wear surfaces include the brake shoes or pads, and also the brake disc or drum. There may be trade-offs. For example, a wear surface that generates high peak force may also wear quickly. Weight. Brakes are often added weight in that they serve no other function. Further, brakes are often mounted on wheels, and unsprung weight can significantly hurt traction in some circumstances. Weight may mean the brake itself, or may include additional support structure. Noise. Brakes usually create some minor noise when applied, but often create squeal or grinding noises that are quite loud. Brake boost. Most modern vehicles use a vacuum-assisted brake system that greatly increases the force applied to the vehicle's brakes by its operator. This additional force is supplied by the manifold vacuum generated by airflow being obstructed by the throttle on a running engine. This force is greatly reduced when the engine is running at fully open throttle, as the difference between ambient air pressure and manifold air pressure is reduced, and therefore available vacuum is diminished. However, brakes are rarely applied at full throttle. The driver takes the right foot off the gas pedal and moves it to the brake pedal, unless left foot braking is used. Because of low vacuum at high RPM, reports of unintended acceleration are often accompanied by complaints of failed or weakened brakes, as the high-revving engine, having an open throttle, is unable to provide enough vacuum to power the brake booster. This problem is exacerbated in vehicles equipped with automatic transmissions, as the vehicle will automatically downshift upon application of the brakes, thereby increasing the torque delivered to the driven wheels in contact with the road surface. Noise. Although ideally a brake would convert all the kinetic energy into heat, in practice a significant amount may be converted into acoustic energy instead, contributing to noise pollution. For road vehicles, the noise produced varies significantly with tire construction, road surface, and the magnitude of the deceleration. Noise can be caused by different things. These are signs that there may be issues with brakes wearing out over time. Fires. Railway braking produces sparks and is an important cause of forest fires. Inefficiency. A significant amount of energy is always lost while braking, even with regenerative braking, which is not perfectly efficient. Therefore, a good metric of efficient energy use while driving is to note how much one is braking. If the majority of deceleration is from unavoidable friction instead of braking, one is squeezing out most of the service from the vehicle. Minimizing brake use is one of the fuel economy maximizing behaviors. While energy is always lost during a brake event, a secondary factor that influences efficiency is off-brake drag, or drag that occurs when the brake is not intentionally actuated. After a braking event, hydraulic pressure drops in the system, allowing the brake caliper pistons to retract. However, this retraction must accommodate all compliance in the system as well as thermal distortion of components like the brake disc or the brake system. Will drag until the contact with the disc, for example, knocks the pads and pistons back from the rubbing surface. During this time, there can be significant brake drag. This brake drag can lead to significant parasitic power loss, thus impact fuel economy and overall vehicle performance.